All right, so we're going to talk a little bit about a few calendar items. First of all, who has not turned in their taxes? They're due today. I mailed mine today. 16 pages on my federal form. It was ridiculous. Oh my gosh. It's terrible. Hope y'all had fewer pages. I also had to file it. I didn't have to file in Oregon, but I wanted my $71 back, so it cost me $40 to get my 71 back. It's kind of
still money in your pocket, it's okay.
Exactly. So anyway, so make sure you got that done. So as far as calendar items here's what I would like to talk about. So today we're going to go slightly out of order. Today is April 17th. It's my sister's birthday today. Wish her happy birthday, everybody.
Happy birthday.
Okay, all right. I'll let her know if she can. She probably won't be interested in the rest of the video, but anyway. Okay, I'm looking at the wrong thing here. So as far as, so today we're going to cover chapter 21. So chapter 21, I should have numbered it chapter 20, but I didn't. On Tuesday, let's see, that's going to be the 22nd, we're going to cover chapter 20. And then, oh, you know what, I'm all messed up. On Thursday, we're going to cover chapter 20. On the 22nd, we're going to have a review. On the 24th, we're going to have the written test, which means I need to figure out the computer test will be somewhere around there. Probably, I don't know, whatever they let me do it, but it'll be.
The last day of class.
I don't really want to come over. You want to send for a review.
Your dates are wrong.
Today's the 17th, right? Thursday is the 19th.
This is the 24th, is the next one.
Oh, this is the 24th. Okay, there we go. That would mean this is the 26th. We're going to have our written test. Then the following, so that will be May 1st, right? May 1st, we're going to have your projects due, okay, which is going to be a day that you will present them in class. May 3rd.
We don't have class.
I don't have class.
That's
Yes, you do.
the last day of class.
Are you sure?
Yes.
I thought it was the second week of May is the finals. Are you sure?
Yeah. I'm taking the final above that. So let's just cancel the project.
Oh. Well, is that true?
You can just cancel the project, that's fine.
I'll tell you what we'll do. This one's kind of optional. We'll just skip chapter 20 then. I didn't know that. So we'll have the review on here. We'll take the test on this day, test 4. I won't make you, okay, so we'll make, this day will be projects due. I won't make you present them then. Projects are due on this day, and we're going to have a review that day. That's Thursday, right?
Yeah.
So I don't know, what day is the final? Is it probably on Tuesday, isn't it? Is it on Tuesday? So it would be May 1st would be the project. Okay, so that means the exam will be here. I think we meet at the same time, don't we?
No, we meet an hour earlier.
Do we meet an hour earlier? So the final exam will be from 10 to noon. Okay, so it is an hour earlier. Now, the other thing is,
Wait, that's not an hour earlier. That's not an hour earlier though, that's what time we start.
it's from 7 to 9 and 9 to 11. So it's from 9 to 11? Okay. 9 to 11 a.m. Okay. Now, the computer final, I believe, is May 1st and 2nd. I'm not sure if that's right. I will verify that here right now. The computer final is April 30th and May 1st, sorry. April 30th to May 1st in the testing center. Okay? Wow. So I guess we'll skip chapter 20 altogether. I didn't realize we were doing that. That's right. So then we're done. Okay?
So there won't be any questions that we're missing from the test. Just skip a chapter.
Yeah, we'll just skip it. So that's all right.
Is the final gonna work out though?
I don't normally, I had really kind of wanted to teach chapter 20, but that's all right. Okay, so today we're going to cover chapter 21, which is the chi-square test. It looks like a Greek letter X, kind of a script X. It's the chi-square test of independence. I thought we had an extra week. I thought we had all this time. All right, well, good for you, I guess.
Just so you know, I just looked at the exam schedule, and so the final would be May 1st from 9 to 10:50.
Yeah.
It's not a lot. Just
Wow.
people don't stress about that extra time.
I'll give you an extra 10 minutes if you want to be late to your next final. I don't care. I'll give you till 11. I'll give you an extra 10 minutes. Okay? Is there a question?
Yes, so is there a rubric or something for the final project?
Okay, final project. I'm glad you mentioned that. We're going to do this. Okay, so final project. Let's talk about that for a second. Okay, now, here's what you should do is the first few slides is you should provide a summary of your national poll. Okay, most of that information you probably have either on your idea sheet or on your IRB form. So what was the question? Who did they survey? What's the margin of error? All of that sort of information. Okay, does that make sense? If they have any cool graphs, use those. So give us a summary, okay? So that's number one. Number two, okay, now how many sampling methods did you do? For each sampling method, you did an SRS, you did a convenience poll, you did a stratified poll. What else was there? Social media, and a systematic. Okay, so you've got 5 polls. That means you're going to do 5 confidence intervals and you're going to do 5 hypothesis tests. Okay? So for each sampling method, you're going to give me a confidence interval, and you will compare to see if it agrees with your national poll, which means you have to interpret it, okay? So that sometimes that interpretation can be difficult. So you've got a group, it's a group project, use your group. If the whole group gets it wrong, it doesn't look good. But it means you're all wrong together, okay? Now, you also, confidence interval, okay? You also need to do a hypothesis test and compare to the national poll. Okay? Number 3, you're going to tell me if they agree. Okay? Now here's what I've found. Typically, most of the time, your confidence interval, well, it depends on what your alternative hypothesis is.
Just when you say never agree and they agree, you mean the confidence interval and the hypothesis test?
You want to know if the confidence interval and the hypothesis test agree. Okay? I probably should have put a step 0 here. Step 0 is give me basic info of the sample. Okay? Which would include the descriptive statistics, like gender, how many are male or how many are female, general ages, that kind. So descriptive statistic. So maybe some histograms, pie charts if they apply. It's means, standard deviations if they apply. Not everything applies to everything. So part of this idea here is you're using the information you've learned this entire semester and then you're making it apply. So For example, would it be a good idea to do a histogram on categorical data? No, it would be a bad idea. Would it be a good idea to do a histogram on quantitative data? Yes, it would. You should have a mix of quantitative and categorical data. What would you use a pie graph for? What kind of data would you use a pie graph for? Categorical data. So a pie graph might be useful. Okay? Make sure, a big mistake on your graphs, use rates, not counts. It's amazing to me how often, I do want to know the counts, okay? I do want to know if you've gotten enough data, but on your graphs, you should generally be using rates, not counts. People love to do counts, okay? You'll get marked off if you do that. So use rates on your graphs, okay? Yeah, so that sort of information. Now, finally, so 0, 1, 2, 3, and then 4, you need similar info for your chi-square test of independence, which is what we are learning today. Okay? That's what we're learning today. So that's today's lecture. Okay? So after today, you theoretically should be able to do everything. Now, whether you can do it properly or not, that's another question. But basically, you need all of this. So 0, 1, 2, 3, all of this for your simple random sample, all of this for your convenience sample, all of it for your stratified social media and systematic. You're trying to compare each of these. So 5 confidence intervals, 5 hypothesis tests. That's what I want. It'll give you a lot of practice. It'll be really good practice for you for the final exam. Because trust me, there's going to be a fair number of hypothesis tests on there. Okay? Hopefully you've got the 7 steps memorized. I may or may not give you those 7 steps. So those are important to have memorized. What's that?
You should just throw us.
Okay. Any questions that anybody has? Yes.
So if we're not presenting it, does the PowerPoint still have to be submitted?
PowerPoint still has to be submitted. I guess we won't have time to present them. That's fine. So yeah, the PowerPoints will be due on the last day of the class. I'll probably be grading them during your final exam. Okay? Any other questions? I really thought we had an extra week. I thought, oh, we'll have a whole week of review, but I guess we'll have a day. Okay. All right. Now, let's talk a little bit about our chi-square test.
Oh, sorry.
Yes.
On the review day for this Thursday, I'm assuming you're talking about
Test for review.
Okay, and then we're having a review of
Yeah, so
semester on the 26th.
that's correct. So we'll have 2 reviews. So we do have 2 review days left. So just to make sure that's super clear, I don't know if people could hear that. So we're doing chapter 21 today. We'll do a review for test 4 on Thursday. We'll have our test 4 next week. I've got to schedule that today, but it'll be in class a week from today. Then the projects are due Thursday. We'll have a final exam review. Ask me anything. So today is the last day you're going to have to learn something new. John.
So when is the computer test for test 4? When are those dates?
I have to schedule that. So that's a little bit up in the air, but it should be around this same dates here. Yes.
What are the chapters for test 4 again?
Everything since the last one. So 17 through, well, technically 21, but we skipped 20. So, yes.
So what you have on the board is everything you're looking for the final project?
Yes.
Don't worry about the M&M, whatever that.
No, this is the M&M. Chi-square is the M&M project.
Okay.
That's what we're learning today.
Okay.
Yeah, this is the M&M project.
What does number 4 say, need what?
Now, by the way, hopefully you've gotten 2 different kinds of M&Ms, peanut and plain or peanut butter or whatever. I don't care what flavor they are, but you need 2 different flavors.
We got some good limited edition flavors of all things, right?
There you go, limited edition. Let's check those out. Hopefully they're not like Oh, it's not February, so they're like pink and red or something, but yeah. Or all green or anything. Yeah, you don't want to do that. Okay? Yeah, it would be easier, but don't do that. All right, so today is actually, believe it or not, I saved the best for last. Okay? Today is one of my favorite lectures all semester. Okay. All right, so here we go. I kind of wish we had a computer lab, but we don't. A university offers two degree programs, electrical engineering and English. Okay? Here, I'll turn on the light if that helps. Okay? Admission is competitive, and women expect discrimination because, you know, it's what you have to deal with, right? Is it fair to conclude discrimination? Okay? All right, so you're given this table. You're now in charge here. We got males, we got females, we got admit, we have deny, and we got 35 and 45 and 20 and 40. So you're the statistician. What do you think? Is there discrimination going on? What might be a simple calculation you could do to figure out if there might be some discrimination going on?
I could divide, well, the total that.
You need the totals, right?
Yeah, the totals that were admitted, do rates instead of counts.
Do rates instead of counts. Very good. Okay, so if we do the totals here, we can see that there were 80 men that applied. There were 60 women that applied. Okay. All right. So you said a rate. So what would be the rate that you would think would be useful, Jordan?
35 divided by 80.
35 divided by 80. Okay, so this shows that 43% of men were admitted to the school and just 33% of women. I think we actually have more women in this class. Usually that's not the case. But women, what do you think? Is there some discrimination going on?
Yes.
Yeah, it looks like it. Girl power, right? All right. So who wants to join me in a lawsuit? You? Oh, okay. Jordan's all, he's very progressive. That's good. All right. So that looks like there might be some discrimination going on, but do you think that's kind of a simple calculation for this class, and I'll let you get away with that?
Yeah. Yes.
No. It's good information, but yeah, so it does look like there might be some discrimination going on, but this isn't like a huge sample size, is it, right? Okay, in fact, let's figure out, we've got how many people here? This is a school of 140, pretty small school, right? This is actually based on a true story, University of California at Berkeley. I've got a little bit more information in the notes. But yes, they actually did file a lawsuit. It appeared that more men were being admitted than women. Okay? All right, but that's much too simple of a calculation for this class, right? We got to do something a little harder, like a hypothesis test, right? Okay, so let's go through our 7 steps that you've all got memorized. What's the first question? Is it categorical or quantitative? What do you guys think? Should we vote? Who says it's categorical? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, a lot of people. Who says it's quantitative? 1? Okay, it's categorical. Okay. What are the categories? Admitted or denied. What are the groups? Groups are male and female. Okay. All right, definitely categorical. By the way, you can also tell that from the rate because those are percentages, right? Percents out of 100. Okay. All right, what's question number 2? Find the null on the alternative hypothesis. Okay. What's the null hypothesis? Well, I will give this to you because this, okay, remember in the past, I've always said that you needed to come up with an equation, right? Today I'm going to break the rule, okay? So what we're going to do in this case is it needs to have the word independent in it, okay? And what we're going to say in this case is that admission is independent of gender. Yes?
Right, okay. With your rate, is that supposed to be the percent, like the percent that's in your chart?
This is the percent admitted. Okay?
So I'm following your notes, and the percent of your male is 57.
Oh, well, this is correct. Sorry.
Okay, so then the female.
That's a
is
different-
42.90.
No.
Okay.
This is correct. Okay? All right. Now, the alternative, you may say the opposite of independence is what? Dependence. Don't use that on the alternative hypothesis. Okay? We're going to say admission is, and I'm just going to capitalize the word not independent of gender, because do you think that they literally looked at your biology and said, oh, she has 2 X chromosomes, so we'll deny her, and he's got an X and a Y, and we'll put that in there? Is there something genetic on there? Admission? Okay. So statisticians are anal. We don't like to say something is dependent. We're just saying it's not independent. There could be lurking variables. Okay? There could be something going on. And maybe there is. In fact, we will find out actually there are some lurking variables in this case. That's why this makes this so fun. All right, what's question number 3? Which type of test? Okay, is it a Z, a T, or a chi-square? Chi-square, because that's what we're learning today, right? Chi-square test of independence.
So how would you know though? Like,
How would you know? That's a great question. That was actually the question I was just going to ask.
We're going to have to choose between all
Okay.
3 of them.
So how would you know that this is a chi-square test of independence? Doesn't have means or population standard deviations. Those were not given. Okay. And a better way to tell is it's always going to be in some sort of a table. Okay. If you see a table in this class, it's a chi-square test of independence. That won't be true for all classes, but for your class, that's the dead giveaway. I gave you a table. Okay? All right, so now I need to give you a couple of equations. Okay? So here's the deal. Okay? Let's say I'm going to make this a 3x3 table just to be a little different than what we're doing here. Okay? So in this case, this is row 1, column 1. Row 1, column 2, row 1, column 3. Row 2, column 1, row 2, column 2, row 2, column 3, row 3, column 1, row 3, column 2, row 3, column 3. Does that make sense how I've got this labeled? Okay. Now, so what you're going to do is you're going to create 2 more tables. One's going to be called an expected table. The expected count equals, and I'm just going to talk about this cell for a minute. It's the row 1 total times the column 1 total divided by the grand total. Okay? I'm going to give you that, but basically, so I picked this one. So it's wherever you're at. If you're here, it's the row 2 total times the column 2 total divided by the grand total. If you're here, it's the row 3 total times the column 1 total divided by the grand total. Question? Can I do what?
Turn the camera a little bit.
Oh, we got a big glare on there. I'm sorry. Okay, does that make sense? Okay, now here's the other equation that you're going to need. The chi-squared value, it looks like a a script, a cursive X kind of. It's the Greek letter chi. Chi squared equals the sum of the observed minus the expected squared divided by the expected. Okay? Now, I'm also going to give you a degrees of freedom. Do you remember your degrees of freedom for the t-distribution? N minus 1. This is completely different. Your degrees of freedom for the chi-square test is the number of rows minus 1 times the number of columns minus 1. I spelled columns wrong, but it's close enough. Okay? Does that make sense? Okay? So here's what I would recommend that you do. Okay? So when you, let's go back to our table here. Okay? So we've got our table. Here's what I would say. I would call this the observed table. This is what we observed. Okay? I would copy this 2 times, but I'm going to erase all the numbers now. So this is now called the expected table. And then I'm going to copy it over here. This is going to be called the observed minus the expected table. Okay? So this is what you should do in order to find your chi-square test of independence. Just copy the blank table twice. Okay? So let's work on our expected table. Now, in order to do this, I'm going to need the totals. Okay? Now, let me show you a mistake that can happen for students if they're not paying super close attention. Okay? It's not going to be a problem today, but it will be a problem if you have a bigger table like a 3x3. Okay? Now, in this case, you remember you've got the auto sum button right here. So you press it and it asks you, is that what you want to add? And you say, yes, I want the row total. And I want that row total. But now watch what happens here when I press it a 3rd time. It went for the column. Okay? Now, in this case, because it's a 2x2 table, that doesn't matter. But if it's a larger table like this, it will actually, you can add it up. In this case, it doesn't matter. It's 140 either way. But if it's a larger table, that will be the wrong answer. So it may be easier, once you've got the formula here, is to paste it there. Now, like I said, in a 2x2 table, it doesn't matter. But in a larger table like this, it will. And I will give you some larger tables. Okay? All right, so we've just come up with our expected. Now we need to do our expected count right here. Okay? So here's where we are. What cell am I in? I'm in row 1, column 1. Okay? So what I want is I want my row 1 total times my column 1 total divided by my grand total. Okay? Equals row 2 total times column 1 total divided by the grand total. Okay, now equals row 1 times column 2 divided by the grand equals row 2 times column 2 divided by the grand. Okay? All right. So now let's just look at this for a minute. Basically what we're saying here, admission is independent of gender. We're saying that the admission rates are the same for men and women. Okay? If that were true, given that we have 140 people here, and oh, by the way, a good check here is to make sure that this adds up to 140. And it did. If that doesn't, you made a mistake. Okay? And it could be because you got one of those totals wrong, or who knows why. All right. So the reality is, if there was no gender discrimination going on, we would have expected the 31.5 males to get admitted. We got 35. So males were admitted at a higher rate than we would have expected. Okay, let's look at the females. If there was no gender discrimination going on, we would have expected 23.5 females to be admitted. We only got 20. Fewer females were admitted than we expected. So maybe there is something to this, right? Okay. So now let's go over here to the third table. Okay, the third table, we're going to use this equation here. Chi-squared equals the sum of the observed minus the expected squared divided by the expected. Okay, so here's what we're going to do. Okay, so I'm going to, and you need to use parentheses or you will get it wrong. Okay, the observed 35 minus the expected 31.5 squared divided by the expected equals the observed minus the expected squared divided by the expected equals the observed minus the expected squared divided by the expected equals the observed minus the expected squared divided by the expected. Okay? All right. Now, what does this mean here? It means I need to find the sum. So I'm going to find the sum of this table. So I'm going to find the sum of this table here, all of these numbers. Okay, now let's think about this. So I got a sum of 1.55. Okay? So let me just demonstrate to you really quickly. Here's the deal with the chi-square test. Chi-square distribution. Okay, so here's the chi-square distribution. Now, I don't know why they put a K there. They should have put degrees of freedom. But you remember that the normal distribution was symmetric and the t-distribution was also symmetric. Okay? This is the chi-square distribution. If your degrees of freedom is 1, that's the yellow line. That's this line right here. Does that look symmetric to you? No, not even close. Okay? If your degrees of freedom is 2, that's the green line. If your degrees of freedom is 3, that's the turquoise line. Now, instead of starting at the top, we start at the bottom. Okay? 4, 6, and 9, you can see all those. Okay? So this one is not symmetric at all. Okay? Now, let me talk a little bit about the chi-square distribution for a minute. I've got a couple of things on the, okay? Oh, did I not put that on there? Oh, here it is. Okay, so let me stop sharing for just a moment. We'll go back over to here. Number one, chi-square distribution. Number one, the shape changes based on your degrees of freedom df. Okay? Number two, it must be a simple random sample. And well, that one doesn't really apply. I've got the population must be normally distributed. That's true if I'm talking about some other distributions. I'm not going to worry about that for here. Okay. Now, rule number 3, though, this is actually important, and I can't remember if I put that on here. I'll add it on there if I do. All counts must be greater than 0. Okay. If that's not true, if you have the 0, then you should not do the test. So I'll put that as A, and then B, no more than 25% can be less than 5. Okay? So let me show you what I mean by that. Okay? Let's go back to here. Okay, so let's say, for example, I have a 0 here. Can I do the chi-square test? No, can't do it. What if I had a 3 here? Can I do the chi-square test? Actually, I put 25%. This should actually say 20%. Okay? Now, so I've got a 3. Now this cell is less than 5. But this is not the cell that I'm worried about. This is the cell that I'm worried about. If that number is less than 5, if more than 25% of those cannot be less than 5. Since that's 13, I'm fine. Okay? Now let's say, for example, that when I was doing this test, that was a 3 when I got my observed value. Can I do the test now? No.
So what do you do when you can't do the test?
So the idea is I'm looking at my expected table. No more than 20% of these cells can be less than 5. Okay? I've got one cell out of 4 that is less than 5. 1 divided by 4 is 25%. That's too high. I shouldn't do the test. Does that make sense? That breaks my rules for the chi-square distribution. So you remember the sample size. What's your sample size requirement for a z distribution or a t distribution? N has to be greater than 30. What's your sample size requirement for a categorical test? Usually we would say n times p times q has to be greater than or equal to 10. This is the chi-square test. What's your sample size requirement? You've got 2 requirements, right? None can be 0. And all of your, no more than 25% of your, no more than 20% of your expected counts can be less than 5. So in this case, I have 25%, that would be a problem. Does that make sense? Okay. All right, now you're gonna have a lot more because I think you've got 6 colors of M&Ms in your bag, right? So your degrees of freedom is gonna change. Let me go back to the way this was, okay? Okay, so I've got my data back the way it was. Okay, so the idea here is, and let me draw a picture here. Now we need to find our p-value. Okay, so typically, here's what I'm going to do. Typically, most of the time, well, in our case, we've got, what's my degrees of freedom in our case? How many rows do I have? 2 rows. 2 minus 1 is 1. How many columns do I have? 2. 2 minus 1 is 1. 1 times 1 is 1. So in my case, I'm like, degrees of freedom equals 1. With 1 degree of freedom, it looks like this. With degrees of freedom greater than 2, it typically looks like this. And in fact, maybe I should add rule number 4, it is not symmetric. Okay? Now, in my case, the alternative hypothesis, remember I said your null hypothesis is independence. Your alternative hypothesis is not independent. Okay, now let's think about this for a minute. Let me go back here for just a second. Now, let's pretend that all these numbers matched. 35, or maybe I'll make them off a little bit. 44 and 21 and 40. Okay? So if this was the case, you can see here that my sum is going to be a very small sum, right? So if there's not a big difference between my observed and my expected, we would say that they match pretty well, right? Does that make sense? Okay. So the alternative hypothesis, you can think of that as always a greater than. You can think of that as a greater than. So we're going to reject if the sum is large. Okay. Now I'll put this back the way it was. So now we have to decide, is 1.55 large? Okay. Now here's how I'll think about this. Now because I've only got 1 degree of freedom, if my alpha equals 0.05, there's 2 ways to figure this out. And you can use the way that you like better. Okay. This is what we call the classical method. Okay. If I pull up my chi-square table here, okay, so this is going to tell me the area on the right tail, so 0.05. Okay, so I'm looking at this column. I've got 1 degree of freedom. I've got 3.841. Okay, I got a value of 1.55. You can think of this as the rejection region. Do I reject or do I not reject? I would do not reject. Okay, now, if some of you may like that method, but the method that I'm going to prefer that you do is, I've got my chi-square test statistic. I need to find my p-value. My p-value equals chi-square dist right-tailed. It's always going to be a right-tailed test for the independence test. I'm going to put in my x value, my chi-squared value. My degrees of freedom in this case is 1. Okay? So this is 0.211. So my p-value in this case, p-value equals 0.211. Is that less than 0.05? So do not reject. Okay? So let's go back to the question. Is it fair to conclude discrimination? There is not enough evidence of discrimination. How does that make you feel, women? Okay? Now, Mark Twain once said, you got liars, damn liars, and statisticians. Okay? When we looked at it first, it looked like there was discrimination going on. Now we look at it and we said there's not enough evidence of discrimination. Who do you believe? Okay? So let me just explain this to you, because it looks like those numbers conflict with each other, don't they? So here's what the university did. They went to the engineering department and they said, well, maybe it's just one of the schools that's discriminating. So they said, engineers, tell us your numbers. They said 30 were admitted, 30 were denied. Your admission rate is 50%, right? 10 were admitted, 10 were denied. Your admission rate is also 50%. So clearly it's not the engineering department that's doing the discrimination. So they said, well, it must be the English department. English, give us your numbers. 5 were admitted, 15 were denied. That's an admission rate of 25%. 10 were admitted, 30 were denied. That's also an admission of 25%. Okay? This is what's known as Simpsons Paradox. When sample sizes are unequal, associations can reverse. And in fact, that's exactly what happened. In this case, I showed you that there was no discrimination going on, okay? Both men and women had the same admission rates in each of the two colleges. The problem is when you combine the men, because the engineering department is so much bigger than the English department, it looks like there's discrimination going on when there's really not. So that's an example of Simpsons Paradox. And in fact, it could be that males had it worse, 29 and 31, and females had it better. In this case, it would show actually the opposite. Men were being discriminated against, not the women. Okay? So that's an example of Simpsons Paradox. Okay? All right, quiz on Thursday is going to be on this chi-square test, and I'll see you all on Thursday.